Magandang araw mga ka-Agham! Ngayon ay tuturuan ko kayo ng another tutorial in the subject physical science, specifically in the branch of science that is chemistry. So, topic natin ngayon is about types of molecular polarity. Let's dive into the topic. So, we have different types of molecular polarity. Ang molecular polarity natin ay under sa two categories. First, we have ionic bond and yung tinatawag natin na covalent bond. So, unahin natin kung ano bang ibig sabihin ng ionic bond. Pag sinabi natin ionic bond, it occurs when there is a transfer of one or more valence electrons from one atom to another. So, ang ionic bond is transferring of an electron of an element to another element. Or should we say, ang pag-transfer ng isang atom or ng isang element ng kanyang electron papunta sa other atom or element, that is ionic bond. So this is how it looks like. So this one is ionic bond. So as you can see, this valence electron is being transferred here to satisfy the octet rule ng itong element na ito. So if you know the octet rule, we have that every valence electrons or valence shell of an atom should satisfy the octet rule. It means the last shell should be 8. Not unless it is an hydrogen wherein or helium wherein the hydrogen meron siyang isa. So it needs only one to satisfy its valence electrons. Satisfy the first shell of the valence, which is 2. Not unless ganun yung nangyari. Ionic bonding exists between metal and non-metal atoms. So, ibig sabihin, lagi nating tatandaan, ang ionic bonding ay nag-i-exist na between metal and non-metal ang kanilang bonding. So, that is the ionic bonding. Now, there is the other category or the types of molecular polarity, that is covalent bond. On the other hand, when two non-metal atoms combine, neither of them loses or gains electron. Instead, electron pairs are being shared by both atoms, and the type of chemical bond form is covalent bond. So, neither sa kanilang dalawa it loses or gains electron. Instead, they pair. So, they share electrons together to bond together. So, it means they need one another to satisfy their valence shell. So, that is covalent bond. Now, for example, how will we determine? Ito yung pinakauna on how do we determine the type of molecular polarity of this compound. So, let's take this example. So, meron tayong periodic table of elements dito wherein naka-color na kung sino si metal, metalloid, and non-metal. So, si metalloid, it is intermediate between non-metal and metal. So, at some point, some of the periodic table of elements considered it as non-metal. Okay? So, let's just focus lang doon sa metal and non-metal. For example, based on our example a while ago, first example natin, meron tayong sodium chloride. So, si sodium, we have Na here, which is metal, and then chlorine, that is here non-metal. So this determines that it is an ionic bond. So that is very easy, right? Then another example, number 2 there, we have carbon dioxide. So meron tayong carbon dioxide. Carbon, we have here that is non-metal, and we have oxygen that is non-metal. So non-metal plus non-metal is covalent bond. Then number 3 is calcium chloride or Cl3. So calcium is number 20, that is metal, and madidetermine mo na siya by that pag nalaman mo na metal na siya, so alam mo na it is a ionic bond. Kasi from that pa lang, na nalaman mo na siya na metal, madidetermine mo na siya na ionic bond. So it is very easy, right? So that is Cl, that is non-metal. So that is IP or ionic bond, or IC, kung ano man yung ating instruction here. So that is very easy. So no need to write that. So this is IC, this is CC, then ito ay IC, CCl4, so it is both non-metals. So that is CC, and we have iron, Fe, and oxygen, that is iron here, and we have oxygen that is here. So it means, of course, alam mo ng metal, so madadetermine mo na IC siya. It is very easy, right? So madali lang siyang intindihin. So before anything else, it is important to note that a molecule is held together by bonds. Remember, covalent bond is divided by 2, that is polar and non-polar. So pag sinabi nating polar bond, it is a generally unfair bond. Again, polar molecules is usually formed when one end of the molecule is said to possess more positive charges, and whereas opposite end of the molecule has negative charges, creating electrical pole. So ano yung unfair bond na sinasabi dito? Ito yung charges. So sa isang molecule there is a charges, positive and negative. So here, ang molecule ay nagpo-possess. So ibig sabihin, there is more positive than negative. As you can see on the illustration, kung makikita mo dito, it is more more positive. Kasi nga, ito we have H2O. So it's more positive than negative. That is polar. Pag sinabi naman nating non-polar, in some reference, pwedeng may hyphen, and pwedeng wala, then magkadugtong. In other references, I don't know if which is correct. So correct me if I'm wrong. So a molecule which does not have charges present. So unlike sa polar, ang polar meron siyang positive and negative charges. Sa non-polar, wala siyang positive and negative charges, due to the reason that electrons are finely distributed, and those which symmetrical cancel out each other are non-polar molecules. Kung papapansin nyo kanina, yung polar is unfair bonding. Ang non-polar, they equally distributed yung electrons sa isa't isa. The polar molecules is determined by 2 factors. Meron tayong dalawa. Aside from the determining using the metal and non-metal, una, we have electronegativity difference and yung geometrical shape ng molecules, which can be predicted via valence shell electron pair repulsion theory. First, polarity of bonds and electronegativity. So, sa periodic table of elements natin, there is an electronegativity present in each element. So, this is the number wherein it is the tendency of an atom to bond. So, ito yung kanyang electronegativity difference. Just like hydrogen, meron siyang 2.1. Lithium, we have 1.0. So, ang pinaka-highest is ito. Fluorine, it has 4.0. Next to that, we have 3.5, 3.0. So, kung mapapansin nyo dyan, sila lang yung pinaka-highest number of electron negativity. So, again, this is a definition of electronegativity. So, what is the connection of electronegativity to the polarity of the bonds? Anong connection niya? We could use electronegativity values of atoms involved to get the absolute electronegativity difference, which help us predicting what type of chemical bond. So, yun nga. Ang electronegativity could help us to determine kung anong type of chemical bond siya. Okay? It's either ionic, polar, or non-polar. So, that exists between them. So, we have here the table of electronegativity difference and the type of bond. So, I was looking for the really exact value sa internet. So, what is the really exact value on the basis of the table? So, as you can see, there is a difference actually. As you can see, we have here, kung ang electronegativity difference, pag sinabi nating difference is the subtraction. Okay? So, the subtraction, this is difference. So, the subtraction between yung number na pinakita kanina sa periodic table of elements between the atom. Okay, so if we have compound and we determine what is the electronegativity of those two elements and subtract it, then ito yung magiging result. So, this will be the basis. This will be the table kung what type of bond, what will be the result of electronegativity difference between that compound, and then this will be the basis. If it is higher than 1.7, it determines ionic bond. Then polar covalent bond, if it is 0.5 to 1.6. Then non-polar covalent bond, if it is less than 0.4. So, like what I've said, they have difference. As you can see, we have non-polar 0.005, 0.5, and 0.06 to 1.9 is polar covalent bond. And then we have ionic, that is 2.0, 3.3 ionic. So, as you can see, there is difference pa rin. So, it means higher than 1.9 is ionic. In this one. So, maybe what will be the provided of your teacher or your professor, kung ano man ang i-provide yan na table, you have to follow. So, I will just teach you how to use the electronegativity difference. Okay, so let's dive in on how to do the electronegativity difference. So, I will use this table to determine the electronegativity difference or type of bond using this table. Okay, so we have here example. You are asked to predict what type of bond is present between the following pairs of atoms by determining their electronegativity difference. Okay, subtract, we have Ca minus Cl. So, in subtraction, mauna dapat yung higher number. Then subtract. As you can see, we don't have a negative sign here. That's why we have to follow the positive one. So, the higher number, then subtract with the lower number. So, we have calcium. Calcium is here. So, let's just put what is the electronegativity of calcium, that is 1.0. Another one, that is the Cl. So, ang kanyang electronegativity is here, 3.0. So, we need to subtract 3.0 minus 1.0, that is equal to 2.0. What is the type of bond? So, the type of bond is, so, ito yung basis. Yun yung kanina. Yung sabi ko na basis on determining what type of bond. So, we have 2.0 that is greater than 1.7. It means it is ionic bond. Okay, number 2 is Cl. So it can be like this. Ganun yung kanyang bond. So Cl 3.0. Of course, same with minus 3.0, that is equals to 0. So it means that is less than 0.4, means it is non-polar. Again, we have hydrogen, that is 2.1. Then we have Cl, that is 3.0. It means 3.0 minus 2.1, that is 0.9. So it means that is greater than 0.5 to 1.6 siya kasi 0.9 ang sagot. So it means it is a polar covalent bond. We have sulfur, that is 2.5, and we have oxygen, that is 3.5. It means we have 1.0. So that is polar. This is polar covalent bond, and we have carbon, that is 2.5, and we have nitrogen, that is 3.0. So 3.0 minus 2.5, that means we have 0.5. So it means polar covalent bond ang number 5. So that is very easy, right? Next, so again, we have the polar covalent bond is formed when electrons are shared unequally. So like what I've said, it is more positive than negative, kagaya ng water. So the pair of atoms for electric dipole represents that arrow. That is, this one is the positive portion, then this one is the negative portion, the arrowhead. Dipole means two poles, which means that the molecules has one positive end and one negative end. So makikita nyo to by the time na i-discuss natin yung last one. And this is how it looks like. So polar covalent bond, in this type of bond with higher electronegativity value becomes partially negative pole, symbolizes this partial negative, while the atom with lower electronegativity value becomes partially positive, symbolizes this partial positive symbol pole. So again, if higher ang kanyang electronegativity, that is negative, partially negative, and kapag lower ang kanyang electronegativity, it is positive, partially positive. So hindi yan siya available sa non-polar. It is because they share equally. As you can see, this is how it looks like. This is more positive, negative. This one, we have hydrogen, that is lower ng electronegativity, which is 2.5. Then Cl is around 3.0. So that is why that makes it this arrowhead, that the positive one papunta doon sa arrowhead is papunta dito sa more electronegativity. And on the other hand, non-polar covalent bond develops if both atoms equally share a pair of electrons between them. So it means wala siyang charges, wala siyang positive and negative. Okay. Later on, we can show that this occurs when the bond of atoms have approximately equal electronegativity value or equal ability to attract electrons to each side. So that makes it wala siyang positive and negative. Now let's proceed sa polarity of molecules and molecular geometry. We're not really go on with molecular geometry. So doon tayo pupunta sa symmetrical shape ng atoms that bond together. So you just have learned to predict the type of bond polarity simply by calculating the electronegativity difference of the atom, specifically 2 atoms. The next question is, how about for those molecules consisting of more than 2 atoms, like the water, molecule of water, CCl4, NH3, and CO2. So what will be? How will we predict the polarity of this molecule? What type of bond? So that is by the molecular geometry or the symmetrical shape ng electrons or ng compound. So ang talaga dito, pinaka-important is the Lewis dot structure. So you have to determine first the Lewis dot structure. So ang Lewis dot structure ng elements. So ang Lewis dot structure is another topic na, but I hope you already know what is the Lewis dot structure. If you don't know kung anong Lewis dot structure, I will do a tutorial on that. Okay. So this is the Lewis, the valence electrons ng elements, and the Lewis dot structure or the diagrams will be shown later. So this is the element. In each element may valence electrons. So we have the hydrogen that says 1. It is because number 1 siya. And we have helium is number 2. It is because number 2 siya. Lithium is 1, but that doesn't mean na number 1 siya. It is number 3. On the first one shell is dalawa. So kanina nga sabi ko nga, the octet rule, which is kailangan sa huling valence shell ng atom is 8. So not unless it is a hydrogen and a helium. Kasi si hydrogen pwede niyang ma-achieve ang kanyang stability kahit dalawa lang kasi nasa first shell naman. And just like helium, this is stable already. It is because it has 2 electrons on the outside shell, just like this. So yun nga, i-discuss ko sa inyo later on kung ano ba talaga yung regarding sa Lewis dot structure. Again, so how will we determine the valence electron of the elements? So kung anong group sila, we have group 1, 2, 3, 4, 5, 6, 7. And we have 8 actually. But then 8 na sila. So as you can see, 8 na siya. It means it already achieved yung octet rule. Okay. So as you can see, 1 siya. It is because sa panghuling shell is isa lang ang natira. It means it is not 8. Just like this, dalawa. The group 3 is 3, 4 is 4, 5 is 5, 6 is 6, 7 is 7. So in throwing the dot or the valence electrons, just like the fluorine, we have the fluorine. So hindi lang tayo pwede basta-basta lang magsulat ng dot. Okay? So dapat ma-follow natin yung box. Okay? So that is on the dot. The Lewis dot diagram. So here we have number 9 siya. Ibig sabihin sa panglast na shell is 7 kasi nasa group 7 siya. So dapat yung sa both side, we have side 1, 2, 3, 4 box dapat. Ang i-follow natin, hindi natin pwede ilagay kung saan-saan ang dot. Then we have here, then there, and then 1, 2, 3, 4, 5, 6, 7. Okay? So ang tawag dito sa pair na ito ay tinatawag natin na lone pair. So tinatawag nating lone pair. So, paano natin ma-determine if it is non-polar or polar covalent bond? Okay, example, we have HCl, which is polar covalent bond. Okay, so let's just write polar covalent bond. Paano nangyari yun? Paano siya naging polar bond? So, pag i-draw natin sa Lewis dot structure or the valence electron niya is, we have Cl here. Cl is number 7, it means nandito na yung 1. So, hindi na natin yung sinusulat ang dot dyan. Usually, this represents 2 electrons. So, we have 1, 2, 3, 4, 5, 6, 7. So, this is already where the electrons na isa. And then, the electron of the hydrogen. So, usually, wala nang dot yan siya. Linya na lang, 1 bond. So, as you can see, it is more positive than negative. Okay, bakit? If you go back with the definition kanina, the higher electronegativity value is partially negative. So it means higher Cl ng electronegativity, which is 3.0, then compare kay H, which is 2.5. It means the positive portion is here and the negative portion is the arrowhead determines kung ilalagay natin siya. So, kung susulat natin siya. So, this is partially negative, then partially positive. Kasi nga, lower electronegativity difference. This is lower electronegativity difference. Then, this is higher electronegativity difference. That's why it is polar. Next, another example ng polar bond is yung H2O. So, we have H2O. So, H2O, we have O, which is 3.5 pala. Then, hydrogen is 2.5, which is higher than the higher one is the oxygen. So, ganito yung kanyang symmetrical for the electron, for the pulse of the charges, which is more negative and positive. This is the shape that cells look like. So, it is polar bond. Then, for another example that makes it conflict is yung CO. Kung CO tayo, it is polar. Why? It is more positive C. A more negative C, partially negative C oxygen. It is because higher electronegativity. But if we have CO2, it makes it non-polar. Bakit? Kasi yung ating central atom is C, carbon na. Then, there is double bond on their valence shell. This is how it looks like. So, they have opposite direction na. Kung babasihan natin yung charges. But then remember, we don't have this one. It is because opposite direction na siya, it makes it non-polar. It makes it electrical symmetry. HCN. So, si HCN, they have the same direction but pointing like this. Let's make this an electrical symmetry that makes it non-polar. So, that's it. That consists our topic for today. So, that's it. That consists our topic for today. I hope you learned something, mga kagham. If you have any concern, just drop your comment on the comment section. Maraming salamat. Hanggang sa muli. Paalam!